Hello and welcome back to our first example dealing with measures of central tendency. So for the first example, I have two different classes. So let's take, in our case, perhaps two English classes, two English for you. So one class is a little bit larger than the other. And they wrote the same exam, and these are the results from those exams. So answering the following, A wants us to determine the measures of central tendency for both classes. Now again, you can do this by hand, but I'm giving you the spreadsheet software to work with. So I'm going to bring it up and show how it works. So I've already entered it into Quattro Pro. So I just created Class A, I retyped it all in, Class B, retyped it all. So it's really up to you. If you don't want to use it, you want to do it by hand, go ahead, feel free. So Quattro Pro equals um, the first measure of central tendency is mean. So equals mean bracket, and I'm going to highlight. And this is Class B I started with those terms there. Oops. I don't know, my Quattro Pro, I seem to have to put at in front of it, the ampersand sign. So the mean, or the average for the class, was 67 for Class B. If I go ampersand median, you'll see it's in there as well. And I'm going to highlight all the values. So the median, the spreadsheet doesn't have to have it in order. It does it for you, so you don't have to rearrange the data. Yeah, you just got to plug in the data, and it'll calculate it for you. So ampersand mode. And again, I'll select the information, and it will go through and look for the mode. In this case, it would be 61. So if I make it look a little nice, a little bit prettier, so mean, median, mode. And I'll do the same formulas here. So ampersand mean, and this is the smaller class, so we'll take it. And median, so ampersand median. Oops, spell it properly, it always helps. And I want you to find the median of that. And mode. And find the mode for Class A. There we go. So there's the information, and I'm going to bring it forward here just so I can bring it to this page to talk about it. So if we go back to Quattro Pro for 1 second, I just want the summary here. Take a picture. Go back to my lesson, and I'll bring it across here. So when you're doing the homework, you're going to be doing the homework in terms of um, if you're using the spreadsheet again, you're just saving the spreadsheet to do the homework in. That's what you're gonna have the spreadsheet to do the tests. So I mean, and the projects. So feel free to use that spreadsheet software. So there we go. So there's a part taken care of it, taken care for us. So determine the measures of central tendency. So A, B part then. Using your results from part A, compare the two classes. So if we compare the two classes, we see that the medians are, and we'll start with that. We look at the median. Okay, the median of 71.73 is fairly close. Okay, so it indicates that Class B did better. If we look at the mean, 71.47 versus 67, it would indicate by the mean that Class A did better. And the mode, it looks like 71 was the most reoccurring mark, whereas in Class B it was 61. So this is typically how it would work. So for Class A, okay, we're pretty safe to say that Class A's performance, 71 was the average, was the median, was the mode. So we know that the class performed fairly well, mainly because all three of these values seem to really match up. So for Class A, the performance can be rated as a 71, if we want to put a number to it. Okay? So we're looking at Class B, the median showed up better than Class A, but the mean was below. So if we just look at the Class B information, we have our median at 73, our mean at 67, our mode at 61. So we're supposed to be comparing the two classes. So I would say based on the information here, we're looking at a high 60 performance, but 61 seems to be the more common number. So for Class B, performance can be rated as a high 60. Again, if you want to put a number to that particular analysis. So if I wanted to compare the two classes together, which information am I going to pick? Mean, median, and mode. Well, when you're dealing with small data, so small data sets, so with small data sets, we prefer mode, or sorry, we prefer median. All right, so whenever you have a small data set, and this is considered a small data set when you're looking at a class of 20 or 30 students, it is a small data set. So median is really what we want to gauge by. So if I'm to compare the classes, I would say that class A and B were pretty close together. So therefore, class A and B had a similar performance. When you're only talking 1 or 2%, you don't really, it's pretty tough to gauge and say class A was, or class B was smarter than A or more successful. It's too small of a range to really make that determination. So C part, what is the effect of outliers on the mean and median? And that leads me to the last part of the discussion here in this example. When we look at the outliers, so if I go back to my, let's look at the data set, I guess, first. When you look at class A, and perhaps going back to the Quattro profile will show that the best. If I arrange class A in ascending order, we see that the lowest mark was a 45 and it extended up to a 95. So 45, 51. So they seem somewhat in the right range. But when I get class B arranged, we notice we have a 12 and a 15. Now those are a significant distance away from the 44, even the 39. Significant distance from the edge of the data. So what we do is we consider the 12 and 15 outliers. So from the original data set, we end up with calling the 12 and the 15 outliers. Now what effect does that have on the data? Well, we said with median, it has very, very little effect. Okay, so if we went back to the data and we assumed that 12 and 15 were eliminated, so I'll delete them. When we look at our new data, we see that the median is now 73.5, but the mean is 71.5. So if I just bring that forward for a second, make the comparison a little bit easier, we notice that there's a bit of a difference when we eliminate that outlier. So if we now do the comparison, we now see that the median went from a 73 to a 73.5. Not a significant change. However, an average, class average of 67 now becomes a 71.5, which is identical to that average of class A, or virtually identical. So when we're looking at part C, what effect did the outlier have? The outlier had a minimal effect, on median, but a significant effect on mean. So you need to be careful when you're doing some analysis or when you're doing analysis, because those outliers play a huge role when it comes to doing your analysis. So keep that in mind when you're looking at your project or the component of the project course. I've got one more example that I want to go through, and I think I have a couple definitions that I want to define. So I will talk to you in the next video.